go through MST. Okay, so MST is going to be the concept in MST is little difficult to remember and understand. So this diagram, hope you're able to see this diagram. In this diagram, we have 3 switches. Okay, out of 3 switches, one has been highlighted in blue, that is has been elected as a root bridge, and the other 2 are non-root bridges. With MST configuration, how are we going to configure is, on the global configuration mode, we are just going to put spanning tree MST configuration. And we are going to split into regions, like I said, right, instances. So we are going to configure all these 3 switches under one region. So that is region 123, 123, 123. We are going. Revision number 1. Revision number 1 is just we can just mention any number as a revision number. But after, whenever there's a network topology change happens, and when the network convergence is happening, at that time, the revision number will automatically gets updated to the next value. So if it is 1 now, after the network topology change, it will become 2. That we need not configure, but initially it's optional only. If we want to do it, we can do it. Else, the revision value, the default will be 0, it will be set. And from there, it will be keep on incrementing. Next comes here, we have mentioned like instance 1 will have VLAN 1 to 50, and instance 2, we have VLAN 51 to 100. So same configuration should be applied in all the switches that belongs to the same region. All the switches that belongs to the same region. This is how we need to configure the MST initially. Okay, this is the initial or the basic configuration that should be applied on the switches. You're able to see my screen, right? The Word document which I'm sharing. The Word document only, right? It's not the text file. No, in my same network, I have an additional 3 more switches. Okay, so what I'm going to do, similarly, I'm going to configure the remaining 3 switches into region 456, like how we did for region 123, region 456, and again the same VLAN mapping has been done for that region. So altogether, all 6 switches are in the same network only. Same comes under same physical, but logically we are splitting the. Just give me a minute, just 1 minute. So all these 6 switches belongs to the same network, but logically we are splitting into 2 different regions. Okay, and mapping VLANs in 2 different instances. So what is going to happen here is, say, we have already splitted VLANs, right? Now, the logical representation will look like this, okay? So, region 123, region 456. And these are the ports which are connecting between the switches. So, these gigabit interfaces are getting connected to each other, right? So, if you go to and see the bridge priority that is configured, okay, so the default MSTI instance 0 region, instance 0 is 4096 for this segment of the network, and this segment we configured as 0. So what happens if you consider only this segment? This is elected as root bridge. Both are designated port, right, on the root bridge. On the non-root bridges, there will be one root port connecting to the root bridge. So here's one root port, here is one root port. This will be again a designated port connecting to the remote switch, and this will be an alternative port, will not be forwarding anything. So for this small logical network, this is how the configuration of the spanning tree election process takes place. And similarly, with this configuration, since it's 0, this is selected, also same designated port, root port, and all election has happened. So when we are going to combine physically these 2 regions connecting the gigabit interfaces. Okay, this is how logically it will look like. Region 456, region 123. Okay, why region 456 is selected as root is because the MST0 is having the low priority over here on this switch. That's why it's elected as a root bridge for this entire network. So here is the root bridge. So the root bridge belongs to this region, and these two ports connecting between these two regions are known as boundary ports. Okay. Boundary ports, the ports that belongs to the remote switches, not on the root region. Okay. The root region obviously will be having the designated port. So from there, which logical network is getting connected, which would be the exit interface for that network will be decided as the boundary ports. There comes the CST and IST, what we have given as a definition initially. So IST is internal, CST is common spanning tree. So this section is the root, is defined as root. This section is defined as a non-root. And the connection between these two regions are called as common spanning tree. There comes the common spanning tree. So what definition we gave for common spanning tree initially? It's the connection between the MST regions. Okay. Common spanning tree is the connection between the MST region and the non-MSTP switches. Connection between two regions. What is IST definition we gave? IST instance will run on each MST region, and it is the only instance that sends and receives BPD within the logical interface. So within this logical interface, the BPDU's packet will exchange. Within this, the BPDU packet will get exchanged. Until unless if this root bridge goes down, the election process will take in this switch, and those BPDUs will be sent to this region as well. If there is any bridge which having lower priority, again, that switch will become as a root bridge. If say this is 0 in our diagram, okay, in our diagram this is 0. This switch is having priority 0. This is having priority 32768. This is having 8194. If this fails, what is the next switch in the network that will be becoming as a root bridge is this switch, because this has a priority of 4096. This is 4098. This is 3264. So this will become the root bridge. If this fails, again, this will not become as the root region. Again, there will be a huge topology change, MST topology change will happen, and this will be elected as a root bridge. So coming to the...
Yeah. So once can you repeat the definitions? I'll just make a note of it.
Okay, definitions.
Yeah, IST.
Yeah, so IST.
Yes.
IST is a special MST instance that runs on each MST region.
Yeah, slowly.
Okay,
Right.
so IST is a special MST instance
Okay.
that runs in each MST region. Each
Yeah.
MST region, or it runs within the region. So
Okay.
this is the connection between the MST region.
Yes.
CIST, common and internal spanning tree, is the combination of ISTs for all MST regions and the CST. Combination of the ISTs. So this is combination of all ISTs in MST regions. So we have multiple MST regions, right? So it's the combination of IST regions. So sorry, IST in all MST regions and CST. CST is the is where we have seen the boundary ports. So there will be one CST only. ISTs is like we have multiple MST regions. We can create multiple MST regions. So here we having two regions, right? Root and a non-root region, and we are having a boundary ports in between. So when the MST regions are connected, each region appears to be one logical switch. So each region is going to appear as one logical switch. So let me put this. This is going to appear as one logical switch, and this is going to appear as one logical switch. But inside there can be multiple switches. In our scenario, we have 3 switches in each regions. But each of that, as soon as we have configured each switches with the different regions, from outside world, it's going to appear as one logical switch. So this is one switch, this is one switch. That's it. That's how the MST is going to work now.
Oh, what does boundary port mean?
Boundary port is where the exit port of the region on the non-root switch or non-root bridge.
Oh, sorry, can you repeat once?
Boundary port acts as the exit port on the non-root bridge. So in this typical logical diagram, if this is the root bridge, this is the non-root bridge. So from the non-root bridge, this is the exit point to reach the root bridge. So these ports are known as boundary ports.
And one more doubt. Like as you said in the root bridge, if the priority of one switch is like lower, then like the next lower priority number of the switch will automatically get assigned as the root bridge if that previous switch gets down. So how it gets down actually?
You want to know how it will go down?
Yeah.
Oh, see, this in the scenario, if this is the root bridge, right? How it will go down? It will go down due to some hardware issue, or it will go down due to power issue. So we will not know in a network when there will be an SMPS problem on the switch will come, when there will hardware will go down. Okay, we need to monitor the SMPS, the power, the fan, the temperature. If the fan is not running on the switch and we have not noticed that for a long time, so what will happen? There will be more heat produced on the switch, due to which the processor will get damaged and the switch will go down. Okay.
Okay.
And if
Okay.
there's a power fluctuation is keep happening on the switch, that is the SMPS, no, on the switch is gone faulty. So the power is keep fluctuating, and we are not aware about that. And all of a sudden, one day it will go permanently down.
Okay.
So due to hardware failure, the switch,
Okay.
at that time there would be a re-election process will happen. So for
Yeah,
that
got it.
only, so for that scenario only, we are configuring, pre-configuring our network with redundancy, with full redundancy, so that if that switch fails, the entire network will not go down immediately. Within few seconds, there would be definitely a network glitch for few seconds, yes. And within a minute, the network will get restored. Users will find that difference. I mean, literally, they'll find that difference in the network.
Okay.
It will due to the network topology change, there will be recalculation in the network and the convergence will happen. Switch will be,
Yeah,
network will be online.
got it. Got it.
Okay, if at all, if we are not configuring any route, I mean the MST configuration, or if we are not configuring any HSRP configuration, VRRP or HSRP configuration, some redundancy, load balancing is not done on the core level, then there would be a huge impact. So MST configuration can also be applied, or you can also configure HSRP. You might have heard.
Yeah.
That can be also,
HSR,
yeah.
it is for two routers, right? When two routers are connected to same switch.
Yeah. Even we can apply it on the layer 3 switches also, HSRP. Similar, whatever we are going to apply the configuration on the network on the
Yeah.
side, same.
Maybe next class you can tell that because I'm unable to imagine how the connections will be.
Yeah. So similar. So we will have one virtual IP address, two physical IP addresses. So virtual will be the HSRP IP. So that concept will come in the routing. So I'll explain that.
Yeah,
So that
okay.
similar configuration can be applied on the switch level on the layer 3 switches as well, in order to have a load balance on the LAN network. So
Okay,
either we
got it.
can go for HSRP VRRP configuration, or we can go with the MST instance creation to load balance in the network, to have a fully redundant and a loop-free network.
Okay.
Okay.
Maybe you can share the commands in the chat or something.
Yeah. I'll share it. That's what I told you. No, I'll share the notes there. You will get the commands. Okay.
Okay.
So this is what we were discussing about the boundary ports. Okay. So like each MST region that are connected will appear as one logical switch. And the spanning tree that connects between the region is called as common spanning tree.
Yes.
Okay. And the
Yes.
boundary ports are connected on the non-root region. Okay. So that will be like as a designated bridge for both the links. Okay. But there won't be any boundary port on the root regions. There is no boundary port.
Okay.
Next. So the common and the internal spanning tree, as we said, is a combination of each region's IST and the CST. Together, we call it as common and internal spanning tree.
Yes.
Okay. So the CIST, the common and internal spanning trees regional root functions as the root bridge of the regions in the IST root. Okay, so in the IST root, so there will be a root bridge. See this picture if you go. So for each IST instance, there will be a root bridge. For this instance, this is the root. For this instance, this is the root. Why this is selected as a root? Because this is acting as an exit interface, okay, to reach the root bridge. That's the reason it has been elected as the root. Okay, so all the ports in the root bridge are designated.
But the priority is 4096 is
Yeah,
less, I guess.
yeah. So even though if the priority is 4096, this is having a direct physical connection to the root region. Okay. When it comes to the root region, these two are directly facing the root region, where the bridge ID for this root region, to which is the lowest, is 816, and that will be as the root.
Is it only in CST case?
This, sorry?
Like it is actually done in only in CST case or anything else? In
Yes,
any
this is,
other?
no, this is only for the CST, yes.
Okay.
This scenario, this election process happens only in the CST.
Once can you repeat that? Like can keep it in words and note.
Okay, which part you want to repeat? Okay, this.
This road bridge election.
Okay, so the CST regional route, so CST route, the switch 5, no? The switch 5 is the CST regional route. This is the regional route has been defined. But on each of the region, there should be a root bridge. Root bridge in the sense to, like, it will be acting as an exit interface to the regional root switch, or like we said, it's the region itself is a logical switch. So the exit interface to the regional root switch will be elected as the root bridge for this particular region.
Exit interface for the regional
Root.
route.
Yeah.
route.
So this will be like typically hard to remember, to understand, but slowly only you'll able to practice this. It's not like the other spanning tree protocols we learned. Okay. So the commands and configurations and all I'll be sharing. The same will be covered, okay, in another session as well for this. So
Okay.
this is the basic understanding of how the election process works and how the configuration to be applied I've shown you the configuration, right?
Yes.
This is just the basic configuration that is being applied. MST, the instances, this is what we are doing actually. Okay.
Okay.
I'll share it. Okay. This
Yeah.
one.
Okay.
Okay, let's park this, because if you're going to discuss more on this, no, it will be confusing only. So let's okay, let me draw something. So here I have one switch, another switch. So this is how the switch is getting connected. So if switch 1 and switch 2, say we want to achieve more bandwidth between these two switches, okay, with full redundancy. Even if the switch 1 fails with this cable, I need another cable to be connected with full redundancy. That should not happen. There shouldn't be a single point of failure in the network. Then I have to go for another redundant link, right? So with this redundant link, what will happen? I'll get double the speed. So if the link speed is 100 Mbps here, I'll get 100 Mbps here, 200 Mbps speed, and my users connected over the access ports on this switch will be very fast. But with the spanning tree enabled on this network, what will happen? The spanning tree will block one of the port, and only one port will be in forwarding state, right? The other port will be in block state. There would be no data forwarding, only one data. So there's no use of having of like having more bandwidth in the network. Even I have multiple links between two switches to achieve more bandwidth, but I cannot achieve that. Spanning tree protocol is disabling the ports, right? But how to achieve more bandwidth, sufficient bandwidth between the switches for my users or servers or network resources to access, I can achieve that with the help of Ether channel configuration. So that's why there comes the word Ether channel into the picture. So what Ether channel will do, it is nothing but link aggregation technology. So link aggregation is each link. So if I'm having multiple links, all the links are getting aggregated, added together, okay, as needed to allow redundant links between the devices. And that cannot also be blocked by STP. And this is the technology we call as Ether channel. Ether channel is nothing but link aggregation technology. Multiple links, even if we have 2 links, 3 links, up to 8 is maximum. Okay. So up to 8 links we have between two switches. We can aggregate all the 8 links to act as a single logical interface. So 8 links with 100 Mbps speed each. So I will have 800 Mbps speed together as one logical interface with a high speed bandwidth between two switches can be achieved without blocking any port by STP. That technology is called as Ether channel. So Ether channel groups multiple physical interfaces together into one single logical link to provide a fault tolerance, load sharing,
One
increased
second.
bandwidth,
Yeah.
redundancy.
One second. Ether channel. Can you repeat it? I'm writing
Yeah.
it down.
So Ether channel is a link aggregation technology that groups
Yes.
multiple physical interfaces
That
together
groups
into a single logical link.
multiple.
Physical interfaces
Is-
into single logical link. So this will be combined as one single logical link together. These two will be grouped under one Ether channel. So what is achieved here is fault tolerance, load balancing, increased bandwidth, redundancy between switches, routers, servers, etc., whatever is connected in the switches. These things can be achieved by Ether channel. Okay, so Ether channel technology makes it possible to combine any number of multiple links between the switches to speed up the switch performance. So it's originally a Cisco proprietary protocol. Okay, but Ether channel consists of two protocols. that is one is LACP and one is PAGP, I think, PAGP. So PAGP is the Cisco proprietary, LACP is the non-Cisco proprietary. Okay, when ether channel is configured, okay, so we are configuring ether channel in a network, combining physical interfaces. So that means we are configuring a virtual interface. We are going to configure a virtual interface, put all the physical interfaces to that virtual interface, and we call it as a port channel. We call that interface as port channel. Okay, so ether channel is a technology, but how that has been achieved? By putting all the physical interfaces, okay, like all physical interfaces into logical interface called as port channel. So the physical interfaces are bundled as I've drawn no in the diagram. It is bundled into one port channel. So what would be the advantages of Ethernet channel is like the most configuration commands or task what we are going to do for Ether channel on each individual interfaces, ensuring the configuration consistency is throughout the links. So even if you are going to apply any configuration on the logical interface on the port channel interface, it is directly getting applied to all the physical interfaces. So you need not go configure on each and every physical interface anything. Okay, so in this scenario, the ether channel is for the trunk interface, right? So for that trunk interface, you're not going to configure each and every port, switch port mode trunk, switch port allowed VLANs or switch port native VLANs. Not necessary. You can apply it on that logical interface of the port channel, and the configuration will be applied. Okay. So load balancing takes place between the links as a part of the ether channel. So load balancing. So if all the links are active, the load from switch 2 to switch 1 are equally distributed on all the physical links. Okay. So ether channel creates an aggregation as seen in the diagram as one link on logical link, and several ether channel bundles between two switches. Then we can bundle. See, this is one interface. We can see I have 8 ports, but all the 8 ports need not be in one one logical interface. I can still bundle into two port channels I can configure. Anything can be done. It's based on a requirement.
Yeah.
So there additionally there won't be any if there is any physical loss, like if there's any one physical link fails within the channel group of physical interfaces, it's not going to create any topology change. We won't able to see any alerts will not come, anything as an end user, or you will not see any difference in the network performance because only one interface has gone down. But when we monitor the switches as a network administrator, we should be alert. Okay, there's one port which is already down, but still network is running, but we need to be very careful to bring up that port as soon as possible. Okay, because if the other port also goes down, there would be a network failure.
Yes, I have one doubt. So, as you said, all the 8 physical links will get aggregated into one logical link.
Right.
So, if one of the physical link goes down, also there will be the connection between the two switches. So, like, if all the 8 switches go down, then like if all the 8 ports go down.
See, in what cases all the 8 ports will go down if there's a switch failure. If the switch itself is down, only all the 8 interfaces will go down.
How does the port go down?
At once, all the 8 ports will not go down. Maybe when there will be port issue, when there will be a physical link issue, when the cable is not connected properly, or something they have disturbed the cable when doing some physical configuration in the server room or in the switch room, or there's a loose connectivity between the cables, or in the patch panel, some loose connectivity at that time only, an interface or a single physical port will go down until unless
Is
there
it
won't be an issue.
Okay. Is it possible to bundle the logical interface?
What logical interface? We don't have any logical interfaces to bundle. We can bundle only physical interfaces.
Yes, can we bundle those?
No, but not possible. Logical interfaces we cannot bundle. So when we are going to bundle the interfaces on the switch, we should not mix up with the interface types. So if we are going to bundle fast Ethernet, it's only belongs to fast Ethernet ports only, 100 Mbps ports. We cannot bundle fast Ethernet and a gigabit Ethernet. So there's a mix of speed difference on these switches. So that cannot be bundled within a single ether channel or port channel. Okay. It should be either gigabit or fast Ethernet. Same interface types should be bundled. Each ether channel or port channel consists of up to 8 compatibly configured Ethernet ports.
Sorry, I didn't understand. Can you repeat it?
No. For each ether channel or port channel which are going to configure, a virtual interface we are going to configure, that is compatible of 8 physical ports.
Why only 8?
That's the limit actually.
Okay, the switch will have only 8 ports.
No. Switch can have a 24 port switch or 48 port switch. Switch can be of any number of ports. But to bundle, see, trunk ports,
Got it.
trunk, in this scenario, we are using 2. Likewise, maximum we can bundle 8. So, but in real time, there won't be 8 ports between switches. But in the case of servers, VMs, VMwares, EXI servers or VMs, high-end servers and all should have multiple ports connecting to the switch. That time it can have 4 ports, 8 ports. So all ports can be bundled into one logical interface. So that port will have an 800 Mbps of speed. That can be achieved on the server side. That's what I've mentioned, like physical interfaces into one logical redundancy between switches, routers, servers can also be achieved. Okay.
Okay, so when the two servers are there, it usually have lot of connections between them. So in order to
No.
reduce the number of
See,
ports,
2 servers is different. I'm talking about single server. Single server will have one IP address. 2 different servers, 2 different ports it needs to be connected because 2 different IP addresses. We cannot combine those 2 hosts into one interface. 192.168.1.1 is one server IP. 192.168.1.2 is one server IP. So 2 different host IPs should be connected on 2 different ports only. They cannot be combined. But if at all, if there's only one physical server, in that one physical server, there are multiple VMs connected, virtual servers, VMwares are connected. So that actually there's one physical device. For that, we can bundle in because 8 VMs, that high-end server will have 8 NIC cards on the server end. See, for a PC or a laptop, we have only one NIC card, right? Connecting the Ethernet cable to the network, to the internet or to the modem. We have only one NIC card. Got it? Okay. Likewise, in the high-end servers, when you go into the real-time network, the high-end servers of a file server or any server, okay, Oracle base, Oracle server, or some software-related servers and all, which is hosting multiple resources. Okay, that's high-end servers and all will have multiple NIC cards. If you see on a desktop machine, at the back of the CPU, you will find only one NIC interface. But in high-end servers, we can insert any number of multiple NIC cards. That should be configured in that way in order to support that high-end feature, to support the entire network or users or database servers. So that will have, that many NIC cards will be directly connected to the switches. Okay, so
got it.
All these physical interfaces again can be bundled into one logical interface.
So Ether channel is it possible to configure between a server and a switch?
No, not at all possible. See, that's what I I told you, two different hosts, two different IP address cannot be combined together. Okay, 192.168.1.2 is one server, 192.168.1.1 is one server. That cannot be combined because physically there are two different hosts. Again, for your question, physically that is a switch and this is a server. The host itself is different. We cannot combine them together. And moreover, the hardware feature is totally different for this. This is a server OS based. That is a
Okay.
switch, iOS based. OS is different. We cannot think of combine. That is not compatible.
So the best possible chance is only between switches and
Yeah, between the switches and servers.
between the servers.
Yeah,
Okay,
high-end
got it.
servers where it has where the requirement will be like on the server end, multiple NIC cards will be there. As far as I know, like there would be 4 NIC cards. All the 4 network cables has to be connected on the same switch and port channel can be configured for that. Else what will happen?
Uh,
MAC address flapping issue will happen because
o-
4 ports, 1 physical device, there would be one for one server, there will be one MAC address, right? That MAC address will be keep on being learned on each and every interface on the 4 NIC cards. Again and again, it will be learned.
oh, okay. So my doubt is Ether channel can be configured between two switches and two servers with different IP address also.
Yes. Ether
Okay.
channel, yeah, can be configured between switches. So ether channel, so like when you have, okay, we
Uh,
put in different words.
switches, switches
No,
and servers with different IP address,
with the same IP address.
with same IP address. I mean
Yeah,
same IP network.
yes. Say, we'll
Okay.
put in a different word. Like ether channel can be achieved when one device is having multiple interfaces connecting. One switch is having multiple interfaces connecting to the remote switch. At that time, all the multiple physical interface can be clubbed, aggregated to one logical interface. So when one server is having multiple physical interfaces connecting to a remote device, so all those physical interfaces can be linked, aggregated, configured as one logical interface. Put it in
So
this way.
these two switches and these two servers should be in same network.
May not be on the same. Just forget about that. That's what I've described in a different way. Just forget about that. That is not the concept. Different network is not the concept.
Okay, and my point is like how the communication will take place.
See,
If you send one ping packet, whether the other switch will retrieve it, that
definitely
what?
yes. See,
Then for that they should be in same network, right?
yeah, same network only. So ether channel concept is on the LAN, local area network. So all the local area networks will be on the same network only, right?
Okay, got it. Yeah.
Yeah.
Once can you repeat the definition? I've written off only.
Okay. So ether channel. So when a device is having multiple physical interfaces
1 minute,
connecting to a
slowly.
remote device,
When a device is having multiple,
physical interfaces connecting to a remote device, those physical interfaces can be aggregated and configured as one logical interface.
those interfaces.
Those interfaces will be aggregated. Aggregated is summed up or added together. Say
Okay.
4 interfaces are there, 100 Mbps. So altogether 400 Mbps speed we will get. So all those all those physical interfaces will be aggregated and configured into one logical interface. So that is ether channel.
Okay.
So ether channel is formed through two protocols. One is port
Yes.
aggregation protocol and link aggregation protocol. So we call it as PAGP and link aggregation protocol, LACP. So these are the two protocols that allow ports with similar characteristics to form into one dynamic negotiation interface. Okay. So it is also possible to configure a static or unconditional without LACP. Okay, fine. So LAGP is a Cisco proprietary protocol. Okay.
LACP.
LAGP, link
Another
aggregation
one.
protocol, LAGP.
Okay.
Okay, that's a Cisco proprietary protocol where the packets are sent between ether channels capable of negotiating itself and forming a channel. So one end of the port is configured as LAGP, the other end is also like capable of negotiating itself to form a channel. Okay. So the ether channel is then added to the spanning tree as a single port. So when the spanning tree is also configured in the network, so spanning tree will see that port as a single port. So we have aggregated 4 or 8 ports together. Still, the spanning tree will see it as a single port. Okay. So it
Okay.
is very important that when we are going to aggregate ports, all the ports should be of the same speed, 100 Mbps or 1 Gbps speed, same duplex settings, half duplex, full duplex, same should be on both the ends, on all the ports as well. So one port should not be uh, half duplex and other port should not be in full duplex. Everything should be same, applied same, verified, and VLANs should be also same. If it is a trunk port, if you're going to allow VLAN 10, allowed VLAN 10 or native VLAN 10, whatever configuration you're going to apply on the trunk on a single port, all the 4 ports should have the same allowed VLANs or same native VLAN configuration. There shouldn't be any mismatch. If any one port is missing any information, then the logical creation of the port will not happen. Okay.
Okay, so what about PHGP and LSCP?
PAGP is again same, like with this protocol only we are going to achieve the ether channel configuration. PAGP
Okay.
is what I've written is port aggregation protocol, Cisco proprietary protocol. Link
Hmm.
aggregation protocol is again ether channels protocol only. It's a non-Cisco proprietary. It can be configured on any switches.
How to configure them?
How to configure that? I'll tell you the commands. So all interfaces, okay, speed duplex and all we've come. Okay. So this configuration, as I said, can be applied on access mode or a trunk mode or a router port. Access port is where we've called like server is getting connected on an access port, which is having 4 NIC cards, 4 physical ports are required and all can be clubbed. Trunk port is most commonly we use it for this thing. So LACP, first we need to configure the port channel and we are going to group the ports. Okay, group the ports and then we are going to verify how it works. So the configuration commands are, say I have, see, first go into the interface. Okay, first we need to configure the interface, a logical interface. Okay, interface. port channel, port-channel 1. So this is one logical interface we are creating. Likewise, the switch can have any number of multiple logical interfaces. So if one is already created, next is 2. You can just mark it as 3. Okay. So now I'm going to create one logical interfaces. So that is a trunk port. So switch port mode trunk, switch port trunk allowed VLAN 1 to say 20, 30, anything, any number of VLANs which you want to allow. This is on the virtual port, logical port that you are going to create. Now comes the physical interface. So this interface is fast Ethernet 0/1 and this interface is fast Ethernet 0/2. Now we want to combine these two interfaces. So go to configuration mode interface fast Ethernet 0/1. There you call this logical interface channel-group mode active. Okay, sorry, group 1, because the port channel what we have described there is port 1. So channel-group port 1. Okay, and similarly, if you want to group the other interface, want to group that other interface also should come under port channel, right? So fast Ethernet 0/2 channel-group same 1 mode active.
This is LACP.
Yes, LACP.
Can you remove the diagram?
Okay.
So what all interfaces we need to combine? We need to manually write every interface, or you can just give the range of the
Range
interface.
command also will work.
Can you tell that? I forgot. Like
Sorry?
range interface or interface range?
Anything you can write. Interface range also. Yeah, we can do interface. See, range 0/.
Okay, that range word will come after fast Ethernet.
Yes, after fast Ethernet.
Okay. I thought range interface fast Ethernet 0/1.
To mention the interface type, fast Ethernet, and then go for 0/1. Without any, you can give space also, or without space also.